Boy, there sure is a lot of frost around here this year. I wonder why that is. Why there's so much frost. Do you know why that is, Dr. Jarvis?
Well, Professor French, when we think about how frost forms, it's important to remember a few things about science. For example, instead of just telling you, why don't I just show you? Now first, we must remember there are three primary phases of matter: solids, liquids, and gases. And all matter is composed of the 118 elements on the periodic table. Now solids, like this ice cube here, they're hard, they're solid, the atoms aren't moving very much and they have a distinct shape, whereas the liquid, which is what's melted from the ice cube here, is more it's fluid. The atoms are moving and it doesn't have a distinct shape, but it does have a distinct volume.
And what about gases?
Well, gases don't have a distinct shape or a distinct volume. They just expand to fill whatever container they're in.
Whoa! What happened to the ice cube, Doctor? It vanished.
No, Professor, it did not vanish. It melted, which is in fact the scientific term for when a solid phase transitions into a liquid. Now, eventually, the liquid on this table will turn into gas, and that phase transition is known as evaporation. Now, when gas turns into a liquid, that is called condensation. And can you imagine what would happen if we were to bring this liquid outside?
It'd freeze?
That's right, Professor, it would freeze.
Oh, that's wild. Now, what about if we were to take some gas and it turned into the solid? Is there a phase transition for a gas to a solid or a solid to a gas?
Funny you should ask, Professor. Frost is formed through that very phase transition. Frost is water vapor, or water in gas form, that becomes solid. This, from gas to solid, is what's known as deposition. Frost forms when an outside surface cools past the dew point, which is the point where the air gets so cold the water vapor in the atmosphere turns into little bits of ice, or frost.
Boy, I guess you could say then that frost is like winter's version of morning dew.
How right you are, Professor.
That's incredible, Dr. Jarvis. But it sure seems like we get a lot of frost around here, though. Why is that?
Well, frost is most common in low-lying areas. Warm air rises and cool air sinks, and that cool air is denser than warm air, which can sometimes mean that there are more water molecules in that air. As the cool, dense air collects in valleys, frost forms. Frost also mostly forms at nighttime when the air temperatures are much cooler. When the sun rises and warms the air around the frosted object, the frost melts quickly.
So you're telling me that we're gonna have to wait out here until nighttime to see frost form right before our eyes?
That's right, Professor.
Well, then this professor is headed inside because it's cold as Charlie Brown out here.
There are even different types of frost. For example, frost can form via radiation when the water vapor in the air near a really cold object becomes solid. Frost can also form through advection, which is when you have a gust of wind blowing across a really cold object, and that results in frost being formed. Rime is another type of frost that forms when fog gathers in areas where the temperatures are below freezing.
So, why then has there been more frost this year than in other years?
Well, Professor, you must remember, frost formation is largely dependent on there being moisture in the atmosphere. As the world gets warmer in places, more water evaporates, and that results in more moisture being in the atmosphere. You could say it is the perfect conditions for frost formation.
Well, I guess we're gonna have to restart the forge and summon the Bifrost.
Thanks again for joining the Professor and I for another Wildlife Wednesday. We are always looking to do some learning, because learning is cool.
And don't you forget it.